Well, last time we started and we studied the key step after estimating the regression analysis. And today what we are going to do is we are going to extend our regression analysis by incorporating dummy variables into account, right? So in a multiple linear regression analysis, we know that we have dependent variable and we have set of independent variables. And then so far, what we have done is we have incorporated number of quantitative or maybe continuous independent variables into our model. But when it's come to our practical analysis, we have to deal with independent variables, quantitative and qualitative independent variables. So therefore, we should focus on both quantitative and qualitative independent variables. So therefore, when it's come to qualitative independent variables, we should know the way how we can incorporate these qualitative independent variables into this model. Then we should study dummy variables, because dummy variables is the way that we should incorporate our qualitative variables into the regression model as independent variables. So with this introductory remarks, so let me move into the today's outline of the session. So initially, so I'll be introducing the dummy variable, and then so I'll be discussing the different types of dummy variable, followed by dummy variable trap, and then I'll be estimating dummy regression analysis with dummy variables. Maybe probably so I'll be taking one or two examples with empirical data sets, and then I'll be interpreting the dummy variable coefficient, which is much more important. So this would be which this might have much more important practical implications, especially relevant to the research and empirical investigations. So in fact, so moving to the introductory remarks, so dummy variable. So if you take this dummy variable, as I mentioned previously, we have to deal with both quantitative and qualitative variables in regressions, right? In previous sessions, we estimated regression models and the regression equation by incorporating number of quantitative independent variables. But not only that, we have to deal with qualitative independent variables as well. For example, gender, maybe the sectors, urban, rural, and state sectors, and then ethnicity, maybe Sinhala, Tamil, Muslim, Burgher, Malay, or otherwise education levels, primary, secondary, and tertiary. But if we take education as number of years of schooling, it's not a qualitative variable, right? Because if you are going to take the education as a number of years of schooling, it's a quantitative variable. But if you are going to take education as education levels, primary, secondary, and tertiary, then it's a qualitative variable, right? Then we should know the way that we can incorporate those qualitative variable into our model. So in fact, so this is the variable, that the dummy variable, that we should learn, that we should study, because we have to get the help of the dummy variable when you're going to incorporate such qualitative variable into our regression model, right? So that's why we should extend our analysis, how to incorporate dummy variables into our regression analysis. So these dummy variables, synonyms with, can be named using the binary variables or the indicator variables. The binary in the sense, the variables that can take only 1 and 0. Because for example, if you take gender, which has two categories, males and females. But if we take the males and females, so those are qualitative, male and female. right? You can write the male and female using text, the letters, but you can't, you can use those things, the letters, when you're going to run a regression. So therefore, what we are going to do is, right, we are going to use this dummy variable, and then we are going to convert, we are going to transform this qualitative variable into quantitative variable by assigning 0 and 1, right? So that's why this dummy variable is known as binary variable or the indicator variables, right? We can assign 1 for the male and 0 for the female, or the vice versa, right? But what you should keep in mind that the dummy variables are important when you're going to incorporate any qualitative variable into our regression model, because dummy variable can be used to convert, transform the qualitative variables into quantitative variables, right? Because I discussed this fact the previous as well. For our simplicity, the previously we incorporate only the quantitative variables, but when it's come to the realistic scenarios in empirical research, you have to deal with number of qualitative variables in relation to your recognized research areas. Then sometimes maybe you have to deal with more qualitative variables than the quantitative variables, right? So therefore, this section, right, this investigation on dummy variables might be much more crucial, especially in relevant to your research areas, right? So therefore, I think now you know, so what is dummy variable and the purpose of learning this one, the purpose of studying this dummy variable. Then the types of the dummy variable. So we can recognize different types of dummy variable in relation to different scenarios. For example, so we have the qualitative dummy variables, maybe the gender, and then ethnicity, and the sectors, and then the education levels, right? Or maybe the poverty levels. So those are qualitative dummy variables. If you take gender, you have two categories, male, because gender is the qualitative variable which has two categories. Gender is a qualitative or the categorical variable which has two categories, male and female. Again, ethnicity is a qualitative or categorical variable which has three categories, or maybe even more: Single, Tamil, Muslim, maybe Burgher, Malay, and some other ethnicities as well. Sectors. In the context of Sri Lanka, so we have urban, rural, and state sector. If you take education levels, maybe we have primary, secondary, and tertiary. And then we can recognize seasonal dummies. For example, we have quarterly dummies, right? The first quarter, second quarter, and third quarter. And then we have monthly dummies. We have the first month, second month, third month, up to we have 12th month, right? So we might have weekly dummies, right? In addition to that, more importantly, we can introduce dummies to capture some policy changes, right? Because in an economy, we can introduce different kind of policies. What I have taken here is basically we can introduce fixed exchange rate and the floating exchange rate, right? And then, okay, during this period of time, so we have introduced fixed exchange rate, but during this period of time, we have introduced flexible exchange rate, right? And then the most apparent example is the war and non-war period. War period, for example, before 2008, right? Before 2008, maybe can be considered as the war period, and after 2008 can be considered as non-war period, right? So therefore, these are kind of very conventional and traditional examples and the types for the dummy variables. You can see when you're reading, when you're going through some research studies, so they have often used these kind of dummy variables for their studies. And also you can use the same for your studies as well. So therefore, so we are going to study these things thoroughly, but I'll be taking a few of them as examples for the today's session. Right. So what I would done here is actually, so I have taken one single example, very simple example, to introduce this dummy variable, right? So then you can see, so I have written down, so I have written down the regression equation. So this is the dependent variable which indicates individual's income. This y variable is a dependent variable which indicates individual's income, and this alpha indicates the intercept term, right? And then this d indicates the dummy variable, right? This dummy variable, and this is how we have defined the dummy variable. This d, the dummy variable is equal 1 for non-smokers, and dummy variable is 0 for smokers, because I have previously mentioned this, that this dummy variable is known as the binary variable 1 and 0, 1 and 0, right? So therefore, the purpose of this UD is, as usual, this is the error term, right? So therefore, the purpose of estimating this model is to capture, right? The capture how these smokers and, so what is the change in this individual's income across non-smokers and smokers, right? We are going to examine whether there is a significant changes of individual's income across these smokers and non-smokers. So this is the purpose of estimating this model, right? And then smoking behavior, it's a qualitative. Smoking behavior is a qualitative. So we can recognize two types within this smoking behavior: smokers and non-smokers, right? When you are going to define this dummy variable, this is how we have defined the dummy variable. We have assigned 1 for the non-smokers, and we have assigned 0 for the smokers, right? When you're going to define this dummy variable, this 0 category is always known as the base category or the reference group. Base category or the reference group, right? Please keep this point in your mind. This is very important. So therefore, in this example, smoking category, smokers are the base category or the reference group, because which has 0. And we have assigned 1 for the non-smokers. Then the based on this definition, we can calculate this, because the y is the average income. Then we can calculate average income for the smokers and non-smokers separately. So moving further, right? Then we can easily calculate the average income for smoker, right? Average income for smoker, because this is how we have defined. We have assigned 0 for smokers. Then all you should do is, we have assigned 0 for the dummy variable, then you should apply here 0, because we have assigned 0 for the smokers. Then to calculate the average income of the smokers, what we should do is, we should apply 0 for this D. Then once we apply 0 here, this part is going to be equal 0. Forget about this error term. Then average income of the smoker is going to be equal how much? 0. Right? Average income of the smoker is going to be equal 0. Then you can calculate the average income of the non-smoker. Average income of the non-smoker. The average income of non-smoker, because again, going back to the definition here, the average, the non-smoker. So we have assigned 1 for the non-smoker. D is going to be equal 1 if a non-smoker. Then assigning 1 for here, because we are going to calculate the average income for the non-smoker, right? By applying 1 here, forgetting this error term again, then beta times 1 is beta. Then the average income of non-smoker is going to be equal alpha plus beta. Alpha plus beta is the average income of a non-smoker. Then it is very clear that average income of a non-smoker is higher than the average income of a smoker. Average income of a smoker, right? So this is what we should calculate, because the purpose of estimating this model is to check whether there is a significant changes in average income across these non-smokers and smokers. Now it is clear that the average income of non-smoker is higher than the average income of smokers, right? Here we have considered only one dummy variable, but we can take one other independent variable here as experience. We can expand the previous equation by incorporating experience. Experience, right? Because experience might be a good factor of their income level. Then we can visualize this one because we have now calculate the average income of the non-smoker is alpha plus beta. Then average income of a smoker is alpha, right? Then we can graphically illustrate this one to have a better understanding. This vertical axis represents the average income. The horizontal axis represents the experience. Then this is the intercept. This line indicates, right? This intercept indicates the alpha. Alpha is the average income of a smoker. And then this intercept indicates the alpha plus beta, which is the average income of non-smoker. So this line is for the smokers and this line is for the non-smokers. Then you will, if you take any experience level, for example, assume that this point indicates the experience level 10 years of experience, right? Right? So therefore, for any given experience level, this is the, right? For this given experience level, this is the average income of smoker and this is the average income of non-smoker. So now it is clear that for any given experience level, the average income of non-smoker is much higher than the average income of a smoker, right? So therefore, to analyze this kind of situation, we should incorporate dummy variables to our regression analysis, right? I think now it's clear because I just wanted to provide you a kind of graphical illustrations to visualize, right, the importance of learning this dummy variable, right? Now, I think you might have a question that, right? Because you know that dummy variable, the purpose of dummy variable is to represent the qualitative variable, right? For example, if you take gender, which has two categories, male and female. If you have sectors, which has three categories, right? Urban, rural, and state. Then you might have questioned that, right? How many dummy variables that we should introduce for gender, which has two categories, male and female? How many dummy variables that we should introduce for sectors, which has three categories, state, urban, rural, and state? How many dummy variables that we should introduce for education, which has three categories, primary, secondary, and tertiary, right? So that is very curious that how many dummy variables and so what is the theory behind this one? Okay, please take this point very clearly and keep that in your mind, right? The number of dummy variables should be equal to, again, the number of dummy variables should be equal to, right, one less than the number of categories of the qualitative variable. Again, number of dummy variables should be one less than the number of categories of the qualitative variable. Again, taking the gender as the qualitative variable, which has two categories. Gender as the qualitative variable, which has two categories. Therefore, how many dummy variable that we should introduce? We should introduce one less than the categories of the qualitative variable. So therefore, for gender, there are two categories. So therefore, gender, we should introduce only one dummy variable. Then for the education levels, we have three categories. So therefore, we should introduce only only two dummy variables. Then for sectors, again, which has three categories. So therefore, we should introduce how many dummy variables? We should introduce two dummy variables, right? So therefore, this point is very much important. The number of dummy variables should be one less than the categories of the categories of the qualitative variable. Just in case, if the number of dummy variable is equal to number of categories of the qualitative variable, then what will happen? Again, just in case, if the number of dummy variables is equal to the number of categories of the qualitative variable, then what will happen? Then there will be an issue which is called dummy variable trap. Dummy variable trap. Dummy variable trap will be occurred when the number of dummy variables are equal to the number of categories of the qualitative variable. When the dummy variable trap is there, the model automatically the model automatically skip the intercept term of the regression equation, right? So therefore, we should omit, we should escape from this dummy variable trap. So that's why we should introduce the number of dummy variables as one less than the number of categories of the uh, qualitative variable. Number of categories of the qualitative variable, right? So therefore, then the category that we are going to drop, for example, if you take this gender, so we have two categories, males and females. If you are going to drop the female category, then this drop category should be considered as the base category or the reference group. So I will be taking that point a bit later. So we are going to interpret the dummy variable coefficient, right? When the dummy variable trap is there, the regression model automatically drop the interceptor. At the same time, when dummy variable trap is there, there will be some kind of issues will be arising. Especially the multicollinearity issue will be there. The multicollinearity issue in the sense, there will be a perfect or strong correlation between independent variables, right? The multicollinearity in the sense, there will be perfect or strong correlation between independent variables, right? This is an issue of this uh, regression analysis, right? When multicollinearity is there, then you will be ending up with incorrect coefficients. Incorrect coefficients. Your coefficients, the estimated coefficient will not be accurate further, right? At the same time, when multicollinearity and when this dummy variable trap is there, you will be facing redundancy issues. The redundancy issues in the sense, because you have interpreted more dummy variables. You have interpreted more dummy variables unnecessarily. Unnecessarily. So therefore, since you have defined, you have assigned more dummy variables unnecessarily, your model will be more complex, right? Your model will be unnecessarily more complex, right? At the end, what will happen is, right, your statistical test, right? Because maybe the t-test and then maybe the f-test or maybe the r-squared values, those will be the misleading. Those will be misleading. So therefore, this point is very much important, right? We should always try to escape from this dummy variable trap. So therefore, before you are going to introduce, before you are going to assign this dummy variable, clearly you should recognize the number of categories of each qualitative variable, and accordingly you should assign the number of dummy variables that should be one less than the categories of the qualitative variable. Then only you can escape from the dummy variable trap. Otherwise, you will be facing number of issues such as maybe multicollinearity, and then inaccurate coefficients, redundancy, And then at the same time, finally, your statistical test will not be accurate, right? So therefore, make sure that you have assigned the correct number of dummy variables into your model. Right. So now let me estimate, the regression model with a dummy variable, right? So I have taken very simple example initially. The purpose of estimating this model is to, right, just to quantify the impact of location on spending, because we know that the people who are living in different locations, right, so their spending patterns are not same, right? The people who are living in the Badulla, right, so their spending pattern might be changed from the people who are living in Monragala, right? So therefore, I just want to examine whether there is a locational impact on the spending. So simply speaking, right, so I have taken spending, the household spending as the dependent variable, and I have taken salary, right? This X1 is the salary of these people. At the same time, then I have taken the location as independence dummy variable. D1 is the location, and then I have assigned 1 for the people who are living in Badulla and 0 for the people who are living in Monragal. So therefore, since I have assigned 0 for the people who are living in Monragala, here in this dummy variable, Monragala is the base category or the reference group. Please take this point very clearly because this is important, right? Then again, the purpose of estimating this regression model with this dummy variable is to capture or to examine, right, whether there is a significant changes in spending of the people who are living in Badul and Monragal, right? Then again focus on the dummy variable. This dummy variable is a locational dummy, right? Because so we have considered in this Uva province there are two districts, Badul and Monragala, and then so I have assigned 1 for Badulla and 0 for Monragala. Since I have assigned 0 for Monragala, right? The Monragala is the base category or the reference group, right? So now let me estimate this regression using this data. So I will show you the data sets, and then I will copy that in this data, and then I will estimate the regression. Right. So this is the data set that I have. This is the salary, and this is the spending, and this is the first dummy variable. Please, so now don't focus on this D2 dummy variable, which is allocated for the gender, right? Because now we are going to focus on only this locational dummy, which is 1 for Badulla and 0 for Monragal, right? And then, so this is the dependent variable dummy, sorry, the spending is the dependent variable, and then the salary is the independent variable, right? D1 is the dummy variable that we have now focused on, right? As you can see, so I have assigned 1 for all the household which are located in Badulla and 0 for all the household which are located in Mondragon, right? So this is how we can create dummy variables in when you're doing research. So this is how we can do dummy variable, right? And then what I'm going to do is I'm going to copy these 3 columns, and then I will paste those things into Stata, right? Right. So I go to data editor and then I copied. So I'm going to paste data here. Right. And then I know that you are familiar with the command. For the regression, we can type reg, assign the dependent variable first. Dependent variable is spending. And then independent variable salary followed by the dummy variable. Right? In this dummy variable, we have assigned one for the Badulla and zero for Monragala for the base category. And then you will see, so this is the regression output. Right? This is the regression output that we have obtained, right? So I have included this regression output for the into this PowerPoint slide. So therefore, I'm going to use the PowerPoint slide here. Right. So this is the estimated regression output, which incorporate the dummy variable. You can see, right? So this is the spending, the dependent variable, and this is the salary, independent variable, and this is the dummy variable, D1, and this is the interceptor. And these are the estimated coefficients, standard errors, T ratios, the probability value on T. And so we have the R squared as well, because you are now familiar with this kind of regression output as we have completed these things in the previous session, right? And then the purpose of this estimation is now, because now we should be familiar with how to interpret the coefficients, especially how to interpret the coefficient of the dummy variable, right? This is the coefficient of the salary, which is quantitative variable. It is much, I think it is much more familiar with you, because so this it's a quantitative variable which we have studied previously. So therefore, so this is how we can interpret this coefficient 0.210, right? 0.210, which indicates when salary change by 1 unit, spending will change by 0.210 units when all other factors at fixed level. Again, right? So I'm going to interpret this coefficient 0.210, which indicates when salary change by 1 unit, spending will change by 0.10 units when all other factors remain the same. Right. Then the problem is how to interpret this coefficient 322.5. This is the estimated coefficient of the dummy variable, right? So this is the new thing. This is the things that you should learn today. How to interpret this coefficient, right? When you are going to interpret this estimated coefficient of the dummy variable, right? You should have a clear understanding about the how we have defined this D1 dummy variable, right? When you are defining this D1 dummy variable, it is clear we have assigned 1 for the Badulla, 0 for the Monragala. So therefore, Monragala is the base category. Monragala is the base category or the reference group. So therefore, we are going to interpret this coefficient in relation to the base category or the reference group, right? So actually this coefficient indicates, right? So actually this coefficient indicates, right? This coefficient indicates the difference of the spending, right? The difference of the spending in between these two districts. The difference of the spending between these two districts. What are these two districts? The Badulla and Monrag, right? But you can see this coefficient is positive. If this coefficient is positive, it implies that spending of Badulla is higher than the base category. Spending of Badulla is higher than the base category. So what is the base category? The base category is the Monragal. So therefore, now it is clear from this estimation that spending of Badulla household is higher than that of Monragala because this coefficient is positive, right? Okay, if just in case, if this coefficient is negative, then what is the meaning? If this coefficient is negative, it implies that, right, spending of Badulla is lower than base category, that's Monragal. Since the estimated coefficient is now positive, so therefore it is clear that spending of Badulla household is higher than the Monragal. Then higher by how many units? Higher by 322.55 units. So that's why I mentioned that the estimated coefficient of this dummy variable clearly indicates the difference of the spending, right, in between these two districts. But, right, take this point very clearly when you're going to define this, the coefficient of dummy variable. Since this coefficient is positive, which indicates that, right, the spending of the considered group, that's the spending of the Badulla, is higher by the base category of Monoragam. So therefore, this is the way that we can interpret the estimated coefficient of the dummy variable. These points are very much important, right? So therefore, you should pay your special attention on this interpretation. The spending of a person who is living in Badulla is higher by 322.5 units compared to the person who is living in Mondragon. Again, so I'm interpreting this coefficient. The spending of the person who is living in Badulla is higher by 222.5 units compared to a person who is living in Mondragon. Right? Now you can estimate the regression with dummy variables. At the same time, now you can interpret the coefficient of the dummy variable. Right? So not only that, but you should be able to check the statistical significance of the estimated coefficient. For example, the estimated coefficient of the salary, this coefficient which is statistically significant at 1% level. Then statistical significance of the estimated coefficient of D1 dummy variable, which is statistical significance at which level? At 10% level, at 10% level. Then the estimated coefficient of the constant term, which is statistically significant at, again, 1% level, 1% level. Then going back to this model again, right, you can determine the overall significance of the model based on this, the probability value on F, right? The probability value on F. So therefore, since this probability value on F is almost 0, right, the overall model is significant at 1% level. At the same time, we can define the value of the R squared, right? We can define the value of the R squared. The R squared value is 0.7199, which indicates 71.99. So therefore, how we can define this R squared value? 71.99%, right? Which indicates that 71.99% of the total variation of the dependent variable is explained by all independent variables. Again, 71.99% of the total variation of spending, that's a dependent variable, is explained by all independent variables. Right. Okay, so now here, so I have considered only one dummy variable, that's a locational dummy. Okay, so now I am going to incorporate one more dummy variable, right? That's the gender. In the previous example, so I have just included the locational dummy, right? Just to check whether there is a locational impact on spending. How spending is, differ across these two districts, Badul and Monragal. Now I have incorporated, D2 dummy variable, gender. I have assigned 1 for the male and 0 for the female. Female is the reference group, right? So therefore, the purpose of including this D2 dummy variable is to capture, so what is the impact of gender on spending? Or otherwise, we are going to quantify So what is the difference in the spending of males and females? Right? So we are going to quantify that. So that's the purpose of including this D2 dummy variable. And then you can refocus on the way that we have defined the dummy variable D2. D2 in the sense, the gender dummy variable, I have assigned 1 for male and female, 0 for female. So therefore, the reference group is female. I'm not going to, estimate this model using data, right? But instead, I have estimated and I have pasted the regression output here, right? So I'm going to explain it. So as you can see, this is the estimated output. So we have estimated coefficient for the salary, D1 and D2 dummy variables. So let me now interpret the coefficients. Right? The coefficient of salary, 0.211, which indicates when salary changed by 1 unit, spending will change by 0.211 units when all other factors remain the same. But D1 and D2, so these two are dummy variables. So we can't interpret as previous. Right? D1, which indicates the locational dummy. Right? Then, again, how we have defined the dummy? We have assigned 1 for the Badulla, 0 for monoragal. So therefore, we should interpret this coefficient in relation to monoragal. So therefore, what do you mean by this 348.10, which indicates 348.10, which indicates the spending of a person who is living in Badul? Again, the spending of a person who is living in Badul is higher by because this coefficient is positive, is higher by because this coefficient is positive, is higher by 348.10 units compared to a person who is living in Monragal, You can see the definition which I have included here. Then, so we have the D2 variable, we newly added dummy variable, which for the gender, right? So we have assigned 1 for the male and 0 for the female. So therefore, the female is the reference group, right? And also you will see here, this coefficient is also positive. So therefore, males spending is much more higher than females. The female, why? Because this coefficient is positive. So therefore, this is how we can interpret this D2 coefficient. The spending of a male is higher by how many units? Right? This is the units. The male's spending is higher by 45.34 units compared to female. The spending of males is higher by 45.34 units compared to females. Right? So I think now it is very clear that the way that you can estimate the model with dummy variable, at the same time, the way that we can interpret the estimated coefficient of dummy variables. Right? Okay, here also same. The estimated coefficient of the salary, which is statistically significant at 1% level. But however, estimated coefficient of the D1 location dummy variable is marginally significant at 10% level. But unfortunately, the estimated coefficient of the D2 dummy variable is not statistically significant. What do you mean by this? Now, D2 in the sense gender. Gender dummy variable is not statistically significant. What do you mean by this? This indicates that gender is not an important factor of explaining household spending. Right? This point are much more important. Right? Because here we have introduced a different dummy variable for gender. The purpose is because we need to examine whether there is a gender variation in household spending. But however, the model says that this gender dummy variable is not statistically significant. If it is not statistically significant, it implies that there is no gender variation in the household spending, right? Or otherwise, gender is not an important factor of explaining the household spending, right? These points you should specifically keep, in your mind. These are very important points, right? Okay. Uh, so I think so with that explanation, so I have come to the end of the session. So just to sum up what I have discussed, so I have introduced the dummy variable, right? The purpose of including, studying and incorporating this dummy variable into regression. And then we discuss the type of dummy variable, then how to define, how to assign the number of the dummy variable and the dummy variable trap, and then the issues with the dummy variable trap, how to overcome the dummy variable trap. And then I have discussed how to estimate the dummy variable, the regression model with the dummy variable, and how to interpret the dummy variable coefficients. So these things are very much important. So therefore, I want all of you to, watch this video again and again, and then you can, have a better understanding about the dummy variable and their interpretation. Right. Thank you very much.